Hello, mathematical friends. Let's do an application of Heron's formula, and that will be to derive the prettiest formula in geometry. Well, maybe the prettiest formula in geometry. I haven't completely made up my mind yet. It's really up there. It's probably in the top 5, or maybe it's number 1. You're going to see and you're going to tell me your opinion also. And now let's recall Heron's formula and how it works. We have a triangle ABC with the usual opposite sides labeled ABC like this. And this triangle's area can be computed entirely in terms of the sides ABC using Heron's formula, which looks like this. And P, what is P? Do you remember? P is, of course, the semi-perimeter of the triangle. You add up all these things, A, B, C, and you get the semi-perimeter. Now, we also proved a bunch of stuff about incircles and excircles, which we will need to recall. So let's get the diagram. Here it is. We have our triangle ABC, and we have a red incircle, and we have the 3 green excircles. And we proved a whole bunch of stuff about this in previous vids, and I will leave links to these vids in the description box. So I'll leave all the Heron stuff, the incircles and excircles videos, I'll leave links to that in the video description box. And the thing that we will need from those videos is the formulas or the relationships for area, and that was RP, where R is the radius of the incircle here, and this is also equal to RA times P minus A. Very beautiful, spectacular relationships that we proved. RB, B minus P, RC, P minus B, P minus C, and RA is the radius of this excircle, RB is radius of this one, and RC radius of this excircle. So we're going to use Heron plus this, so this stuff plus Heron, to derive what could very well be the prettiest formula in all of geometry. Okay, so let's get to work on that. There's a bit of algebra to do to get to this beautiful formula. Let's start with those incircle, excircle area relationships, and I've written them down here. And let's square everything. So this is squared, 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 and squared. Okay, and let's solve. Okay, so our strategy will be to solve for all these things, for R, RA, RB, and RC, and see what we get. So we'll solve in terms of ABC and the area ABC squared, this squared area, and the semi-perimeter squared. So let's start. So R squared is ABC squared over P squared, yeah. But ABC squared by Heron's formula is P times P minus A times P minus B times P minus C. We're going to write this a lot, so you have to be patient here. Over P squared. Well, some of this vanishes. This and this disappears. And we have P minus A, P minus B, P minus C. Okay, very good. All right, let's keep going. So RA squared will apply the same concept, ABC. You'll see it's the same thing over and over again, but it's a very beautiful pattern that emerges that makes all this not really tedious at all, but actually quite interesting. P minus A by Heron's formula are this area on top, ABC squared, has to be equal to this. I take away the square root because I've squared it, yeah, over, now this is p minus a squared. Well, we have more things that disappear. One of these goes away, and I have p minus b, p minus c. I hope I don't make any mistakes doing. It's so easy to make a mistake when you have wall of, yeah, I just made a mistake. You see, look at this. This should be a p here because I've canceled out one of these p's goes away, but not both of them. Okay. So you see, it's so easy to make a mistake when faced with a wall of algebra like this, okay? But this is not ugly algebra. This is like super beautiful algebra. You'll see the way it all comes together is just so elegant and remarkable. P minus a, p minus b, p minus c over p minus b squared. Let's hope I don't make any more mistakes. Okay, let's cross this out, and this goes away. And I have p minus a, p minus c over, look at this beautiful patterns which emerges. My p looks like a b, p minus b, right? And one more, and we're ready for the final approach to the most beautiful formula in geometry. Okay, and I do the same here. P minus a, by Heron's formula, p minus c. I like writing this. P minus c, because I know it goes somewhere. It's not just a mountain of symbols. I know that it's getting somewhere. And that's why I like it. I know that there's light at the end of the tunnel. P minus a, p minus b over p minus c. Again, this kind of a cyclic pattern that emerges. Well, what should we do now? Well, what I'm going to do is multiply everything together. R squared, RA squared, RB squared, RC squared. All right. So this is like a huge mountain of stuff. So let's write this carefully. P minus A. Actually, what I'm going to do is I'm going to do a cut and just write everything out because I'm not doing anything that needs too much explanation. All I'm doing is taking these expressions and multiplying them all together. And I'm not going to do any simplification. I'm just going to write them all out here. And then we'll do the simplifications together. Okay, there's everything. So I just took these 4 expressions and I put them all together, multiplied it out. And now let's use some colors and try to eliminate some stuff. So let's cancel out this and this. So this goes away. Let's cancel out this and this. That goes away. This and this, this and this. And let's see, what are we left with now? Okay, okay, I'll use more colors. There's one of these and one here. So there's a p minus a. I'll write it over here because there's a p here and a p here. So that's squared. Almost forgot to square it. Almost made a blunder. Almost. And now, let's get more color. P minus B. There's 2 of these. P minus. You see where this is going. Isn't this beautiful? I mean, the derivation itself is just as beautiful as the formula. You know, it's just as pretty. And there's one more. There's the C here. And that's like this. P minus C squared. Okay, so, well, I have all these squares. I don't need the squares anymore. I wrote all these squares because I wanted to avoid writing a lot of square roots. So let's take the square root of both sides. I have R, RA, RB, RC. This is P minus A, P minus B, P minus C. But what is this? You know what this is. By Heron's formula, this is area squared. So this is A, B, C, area of the triangle squared. And so therefore, I have my final formula. The area of that triangle, ABC, is the square root of the product of all of these radii of those special magic tangent circles. The 4 tangent circles, you multiply them together, the radii, you take the square root, you get the area of the triangle. Have you ever seen something as beautiful as this, really? I have seen a lot of beautiful mathematics, but I mean, some things are just really a cut above. Beautiful. This is just a beautiful formula. Well, like usual, if you like this video, if you like this formula, click like. And in the comments, let me know what you think of this formula. Do you think that it's in the top 5, that it's number 1? I think it's a contender for number 1, prettiest geometry formula. I can't really think of anything that tops this right now. I have a few things in mind that maybe I'll show you in the future that come close, but this is really, I mean, it's just unbelievable. And it works out dimensionally too. There's 4 factors of dimension length. So when you take the square root of that, it's length power 2, and that's area. So it makes sense dimensionally. Well, I was really glad to have shown you this. Okay, this is a beautiful formula. And I will see you next time.